Hello students, welcome to lecture 5 of alcohols, phenols and ethers. Here let's learn a preparation of phenol. Write the heading, preparation of phenol. So first preparation. Now what is phenol? Phenol is this OH connected to a benzene ring. Actually benzene, how this name came? This benzene is also called as phenyl. Okay, you put one OH on that, last YL will be replaced with what? OL. So this is phenol, and this is not alcohol. It is another functional group. Okay, phenol. It for not a functional group, but it is going to have a different. This will be a different chemically different from the alcohol. Okay. So first preparation of the phenol, that is from haloarine. From haloarine. So from haloarine means what? Chlorobenzene. Over here, chlorobenzene is a good example of a haloarine. Chlorobenzene is fused with NaOH, is fused with sodium hydroxide at 623 Kelvin and 320 atmosphere pressure. Okay, this is the pressure, right? So further, it is phenol is obtained. Phenol is obtained by by acidification of sodium phenoxide. So produced. So we'll understand what is the meaning of this statement. So this is the chlorobenzene. This is a chlorobenzene, right? This is a chlorobenzene. You simply cannot break this bond. Remember, just put a OH minus or a source of a OH minus. You cannot break this bond because there are many reasons for this. We have learned this in a haloalkane, haloarine also. There, what happens? A partial double bond character is there. Then electronegativity of this carbon of the sp2 is comparatively more than sp3. So this leads to a shortening of the bond. Both are good electronegative elements, right? This carbon and this halide, so shortening of the bond. Then if it wants to go via SN1, that is formation of the carbocation, then positive charge will form on the double bond, that is most unstable. So there are many reasons because of which this bond cannot be broken very easily, right? So we require what? We require a very high temperature. So I want to add a NaOH over here. I want to add NaOH, but this substitution is not going to happen at an ordinary temperature. So you require a temperature of 623 Kelvin. Okay, this much temperature, pressure 300 atmosphere. You can see 1 atmosphere and where is 3 atmosphere, it is 300 times more, very high pressure. So in that case only you can break the bond, and what you get at this step is this ONA. So what is the meaning of this? This is a sodium, this is sodium phenoxide. This is called as sodium phenoxide. And this is your halo or chlorobenzene. Haloarine means chlorobenzene. This is chlorobenzene. This is chlorobenzene, right? So this is done. Further, what you do is you just put acid on this. So you are adding an acid, which is a strong acid. This is O minus, this is Na plus. So Na is a group 1 element. This H is also placed in a group 1 element. So it will replace a Na over here. So what you get is phenol in this case. This is what the phenol you get. And plus NaCl will be a byproduct over here. NaCl will be a byproduct. So this is one a fixed reaction. You don't have to worry about here a carbocation formation or a rearrangement. All these mechanisms are really not important with respect to this. You just know this. Hello arena. This is hello arena. Just know this reaction, what happens in the reagent. Um, then next is from benzene sulfonic acid. Next is from benzene sulfonic acid. Next preparation of phenol from benzene sulfonic acid. Now, what is the meaning of benzene sulfonic acid? This is what the benzene sulfonic acid is. Benzene and SO3H. This is what the benzene sulfonic acid, right? How this is prepared? It is prepared. First, we want this, right? Although we are using a benzene sulfonic acid, how it is prepared? It is prepared this way. You take a benzene, you take a benzene, and react this with H2SO4, H2SO4, and SO3, right? This mixture which is there, it is called as a oleum. In other words, this is called as a oleum. So oleum is also H2S2O7. Remember, on a arrow, they can show you this way also, H2S2O7. This is what the benzene sulfonic acid you are getting. So further, what is done is NaOH. You add a NaOH, sodium hydroxide. So this is a base and this is a acid. Remember what I am saying over here. This is a acid, no? And this is a base. How to remember this? You are going to get a salt out of this. When there is a salt, so whenever this is the simplest rule which we learn from the lower standard, 10th standard, right? That is when acid and base reacts, what do you get? You get a salt and water, right? So from this, I'll not write the water over here since it is a sequence of reaction. I'll just write minus H2O, means water is subtracted from this. Means what is the salt you are going to get? Can you predict the salt? Salt is this SO3. It will replace Na over here. It will replace hydrogen over here. Na will replace that, right? So this is sodium benzene sulfonate. The product what you are getting is over here, not a final product, sodium benzene sulfonate. Further fused NaOH, further it is fused NaOH. Again, temperature required is very high, 573 to 623 Kelvin, right? This is the temperature. So what will be subtracted from this? I'll write over here. Subtracted means as a byproduct, it will be getting as a byproduct over here, minus 2. So the product form is sodium phenoxide. So this is what the product is. This not the final product, but product what we are getting is a sodium phenoxide. Now you know how to prepare a phenol from this. Just add HCl. It is a part of a first reaction we did. So this is what the phenol you are going to get. This is phenol, and it is that simple. It is very easy to remember these reactions. Next is from a diazonium salt. Third preparation method is from a diazonium salt. From diazonium salt. So what is diazonium salt? Since we want a benzene, since we want a phenol, right? Since we want phenol as the main product, so what diazonium salt we are going to take? Diazonium salt over here choose is a benzene diazonium salt. So how does the benzene diazonium salt look? It is this way. It is written a benzene. It is N2 plus Cl minus. It is a salt N2 plus Cl minus. Uh, this is what the benzene diazonium salt. This is a structure of benzene diazonium salt. Now this N2 plus what I have written, actual structure is this way, diazo. There are two azo groups. Nitrogen here, positive charge. Because this nitrogen is making four bonds, you can see usually nitrogen forms three bond, that time it is neutral, means there is no charge. And when it forms a four bond, there is a positive charge. And this is a counter ion, Cl minus. That is how it is a diazonium salt. See, this bond is not very stable. Now it is not like a halide. There was a lone pair of electron. It was forming a partial double bond character due to resonance. This bond is very unstable, right? Why? If this bond is breaking, then what you get is a nitrogen gas. Means you are going to get one product is there, one reactant is there, it could be converted into a two product. So this bond is like very easy to break, most easy to break. This bond, diazonium bond, this bond is very easy to break, very easy to break. So in this case, what is done is it is reacted with water and just warm it, s- supplying very less amount of the heat. Means in that case also you are going to get a phenol. In that case also you are going to get a phenol plus nitrogen gas as a byproduct and a HCl. So this is the preparation from a diazonium salt, benzene diazonium salt. So you must be knowing, how diazonium salt is prepared. Like you take a aniline, I'll just write this how it is prepared. It is aniline reacted with a HNO2, HNO2, and this gives you a diazonium salt. Actually, HNO2 means what? It is shown this way also. NaNO2 plus HCl. HNO2 is prepared in situ. This is called as nitrous acid. Just extra thing, not not required for this reaction. Nitrous acid, right? How diazonium salt is prepared. That is what the thing over here is. Next is from cumin. Preparation of the phenol from cumin. Both from cumin. Now, what is the meaning of cumin? Cumin is isopropyl benzene. Cumin is isopropyl benzene, right? So I will write this isopropyl benzene. How it looks? Isopropyl benzene. Iso means one methyl group on a second carbon, right? So this is first carbon, this is second carbon, and on that case there is one methyl group. So this is isopropyl. Total is three carbon. Right? There are three carbons, so isopropyl benzene. And this is also known as a cumin. Isopropyl benzene. Right? What is done over here is oxidation. Right? A trick over here is that this is carbon and hydrogen. Just put two oxygens over here. I'll not discuss the mechanism. Just put two oxygens. Where here you are putting two oxygen, peroxide. It is peroxide means what? Oxygen and oxygen are connected directly where the oxidation state of oxygen is -1. That is what the peroxide. No, peroxide means what? Here this is a peroxide. Uh, Oxygen, oxygen is in -1 oxidation state. Oxidation state. That is what the peroxide, right? So this is called as a cumin hydroperoxide. Cumin hydroperoxide. And further, in the presence of H plus, I guess what we are doing over here is hydrolysis, acid hydrolysis. Hydrolysis means breaking of bonds using water. Okay, breaking of bonds using water. So in this case, what you get is phenol You can just connect, you can relate it, this OH and this. And other product what you get is a ketone, that is CH3 C double bond OCH3. That is acetone you are going to get. So main product is a phenol over here, and the other is acetone. This is also known as a propanone. It's also known as propanone. Next topic over here, we are going to learn about the acidity of the alcohols and the phenols. Right? Next topic is acidity of alcohols and phenols. Now, what is the meaning of acid? If I ask you what is the meaning of acid, what is acid? Acid, one of the definition of acid is that a species which can donate its H plus very easily, very easily. That is what the acid is, right? So now let us understand the acidic nature of this. So there are certain reactions. First, I'll discuss with the reaction, and then we'll compare the acidic strength of the acid, that is the alcohols and the phenol. How which is more acidic and which is more basic. So here, what we are discussing overall is the acidity of the alcohol. Means what is the acid? A species which can donate its H plus very easily. Like if many times we say this that is CH3 COOH is a weak acid, but HCl is a strong acid, right? When we say this is a weak acid, right? We say that acetic acid is a weak acid, but whereas HCl, it is a strong acid. This is what we say. What is the meaning of this? Why we say it this way? Say here, this is a weak acid due to, like, when it dissociates. If I put this into water, what I'm going to get is CH3 CO O minus and a H plus, and I'm writing aqueous around this. Aqueous means water is surrounded around this H plus. So here, if we start at time t is equal to 0, okay, then this is, let's say, 100 molecules I have taken 100 molecule, and at time t is equal to equilibrium, means where the reaction goes to a maximum extent. That time what you will find that only 5 out of 100 has dissociated into this. Means how many H plus you are getting? You are just getting 5 H plus. But whereas in the case of HCl, see here, this has this concept. I have included a carboxylic acid and HCl. Although the topic is alcohol and phenol, I'm just wanted to tell you what is the significance of the H plus. What is the meaning of acid? Or what is the meaning of good acid or a strong acid? This is a strong acid. This is like 100 HCl I have taken. And initially at time t is equal to 0. At time t is equal to equilibrium. Equilibrium means equilibrium won't exist over here, but still I say the equilibrium is maximum time. So what I observe is that you are going to get a H plus aqueous and a Cl minus aqueous. Means what? Cl minus aqueous means water is surrounded around it, all these ions. So initially it is 0 and 0 at time equilibrium. What will happen? This is 0 and this is 100, means all the HCl is going to split. So where you are getting more number of the H plus in the case of strong, right? Although there are more number of hydrogen in this case, you are just getting 5 H plus. Here you are going to get just like, although only one H plus, you are going to get 100 H plus, means per molecule it is 1, right? So this is a strong acid. Now, is it possible to identify the acid just by looking at the formula? Answer is no. It is experimentally. This is experimental, right? This is experimental. So now coming back to the reactions of this alcohols with the different. So if I ask you which are the most reactive elements of the periodic table, which are the most reactive elements of periodic table, right? Which are the most reactive? If elements had faces, then which are the most reactive? Like, I will say answer is group 1 and group 2. Answer is group 1 element, group 1 element and a group 2. These are the most reactive elements. Group 1 and group 2 are the most reactive. The reason is that group 1 is bigger size of atom, easy to easy to remove electron, outermost electron, and after removal of one electron, they attain they attain noble gas configuration. Noble gas configuration. Like here, this is what? Here, removal of two electron, that is also fine, but this is more reactive. Removal of two electron leads to noble gas configuration. Noble gas configuration. Right. Finally, a dream of every atom. I will highlight over here why reaction takes place. Why reactions takes place. Dream of every atom. What is the dream of every atom? What is the dream of every atom? To attain noble gas configuration. We must be having a different dream. We want fame, we want money, we want respect, so many things. But atom just want 8 electrons in the outermost shell. So to attain noble gas configuration, noble gas configuration. So group 1 element are the most reactive. So let's react with those elements only. So among that, we will tend to react a sodium. We'll do the reactions of the alcohol. So if there is a alcohol, the first reaction with reactions with metals, with metals, reaction with metals. So answer over here is, let's say this is alcohol. This is alcohol, and you react this with a sodium metal. So this alcohol, which I have written over here, OH, this sodium. If you see, what does the sodium will do? Sodium is able to give away its hydrogen very easily, right? Sorry, not hydrogen. Sodium will be able to donate its electron, okay, or lose its electron very easily, very easily. What is the reason for this? Why it will lose electron very easily? By losing electron, sodium will change to what? Sodium will change to what? Na plus. Means electronic configuration of the sodium is 1s2, 2s2, 2p6, 3s1. This is the electronic configuration of the sodium. When you lose one electron, what is the configuration of this? 1s2, 2s2, 2p6, right? Because 3s1, you are removing this electron. So this is a noble gas configuration. So here, therefore, sodium will lose electron very happily, very happily. Sodium will be very happy to lose electron, right? Because it is going to attain a noble gas configuration after the loss of electron. Now, who will gain that? Who will gain that electron? Like this is a very over here. This bond breaks, then it will form a H plus. This is ready to give a H plus, right? So here, what forms is R O, that was Na plus. I'll clean this. I will show stepwise what happens. So this is fine. You must have understood. Sodium is waiting to give its electron. Sodium is very happy to give away its electron. So in the aqueous medium, what happens here? What is going to happen is that this RO minus will split as a H plus, and the electron from this will be there. one electron will be there, and this Na has changed. So this will combine to form H, right? And this will combine to form sodium alkoxide. So this is sodium alkoxide. So this is plus, no, this is plus and minus, and this plus and minus. So this gives me a half mole of H2 gas, half mole of H2 gas. This will give me half mole of H2 gas. Like I can write this will be converted to half mole of H2 gas. Like you consider two hydrogens combining, two electrons will be donated. It could be written this way, or you can write it this way: 2, 2, and 2 and 1. You can write it this way also. So this reaction, the preparation, what you get over here is a sodium alkoxide, alkoxide, right? And this is hydrogen gas will be released from this, right? So here hydrogen gas will be released. So this is a reaction with a metal. Now what we can do is second is reaction with a aluminium. If we take a tertiary alcohol, we take a tertiary alcohol. Tertiary alcohol like this. Um, CH3, CH3 here also. CH3, this is OH. This tertiary alcohol name would be what? 2-methyl propane 2-ol, right? This will be a name. You can consider this as a parent chain. If this is reacted with the aluminum, like now you think of the aluminum, like aluminum requires how many electron to attain, like how many electron aluminum will lose to attain a noble gas configuration? Answer will be very simple. Aluminium's atomic number is what? 13, right? Aluminium's atomic number is 13. Its electronic configuration is 1s2, 2s2, 3p6, sorry, 2p6, 3s2, 3p1. It will lose 3 electron. Then if it is aluminum is changing to aluminum 3 plus, then it will attain noble gas configuration, right? 1s2, 2s2, and 2p6. So aluminum will tend to lose a 3 electron, means aluminum is going to change to aluminum 3 plus, right? So I require a hydrogen. One hydrogen can accept only one electron, right? So here this aluminum alkoxide will be formed. How that will be formed? I will write a balanced equation finally. CH3, C, CH3, this is CH3, O. This is aluminum. This is thrice. Okay, this is connected. This is three times, three molecule. Because one molecule of this is minus, no, and aluminum is 3 plus. Means I'll just clean this and show you. One molecule of this in the reaction intermediate, if this hydrogen is lost, it will give you O minus, right? So how many O minus will require to satisfy Al3 plus? Because this Al is changing to what? Al3 plus, no? So you'll require 3 units of this, right? And plus hydrogen gas will be released. Some hydrogen gas will be released, right? So to balance this out, what I do is I'll put 6 over here, I'll put 2 over here, and I'll put 3 over here, and I'll put 2 over here. Yes, right? Or if I want to show it this way, this will be like 3 by 2, 3 by 2 mole. Now it is balanced. But if you multiply, uh, yes, yes. So what we can do this directly. We will put balancing directly 6. This is 2. Then this is 2 moles, and this is 3 moles. So everything is balanced. So what is the point over here is that hydrogen, it is a displacement. It is hydrogen gas is released over here. Right? This is a hydrogen gas, a very effective method because one of the byproduct is in the gaseous form, and this shows that alcohols are very acidic, means they are ready to give away its hydrogen. This reaction proves that they are easily available for the donation of the hydrogen. They are easy, that's why hydrogen gas will be formed, right? Then we talk about a phenol. We take a phenol, we take a phenol. This is OH. This is OH. We are taking a phenol over here, and I'm going to react this with a NaOH, right? Sorry, not NaOH, just Na, just Na. So what would be a product over here? It is a sodium phenoxide, no? It is Na, that is sodium phenoxide you are going to get, because it will lose its hydrogen. Like in the intermediate, this will be forming O minus and a H plus, and this Na will change to Na plus, and there will be an electron due to Na. So always this is going to combine and this is going to combine. And here hydrogen gas will be released. Hydrogen gas will be released. Let's put this 2 and 2 over here. And this also 2. Right? Sodium phenoxide. This is sodium phenoxide what you get. This also proves the acidic nature of the alcohol. And this alcohol means this is a phenol. Now if it is reacting like phenol is reacting with a base NaOH, right? With a base. So what would be a product? The product would be this way. A sodium phenoxide instead of alkoxide, instead of just H2 gas, what you get is water. What you get is water. Sodium phenoxide, and instead of hydrogen, you get a water as a byproduct. This is phenol. Let's compare the acidity of the alcohols. So let's compare uh, comparison comparison of acidity of primary, secondary, and tertiary alcohols. Among this, which alcohol will be a most acidic? So here I'll write the example. Directly, I'll not write a general formula, I'll just write the examples of this. So this is an example of a primary alcohol, right? A secondary alcohol will look this way. Secondary alcohol will look this way, right? And the tertiary alcohol will look this way. So I'm comparing between what? Here comparison of the acidity of the primary, secondary, and a tertiary alcohol. I'm comparing it between a primary alcohol. So this is primary alcohol, right? Here this is secondary alcohol, and this is tertiary alcohol, right? So here OH is connected to a carbon. Further, it is connected to only one carbon. That is what the meaning of primary. Here OH is connected to this carbon. Further, it is connected to only two carbon. This is secondary. Here OH is connected to this carbon. Further, it is connected to three carbons. This is tertiary alcohol. So what is the meaning of acid? Meaning of acid is that it will split. Okay, it will split this way. It will split CH3, CH2, O minus plus H plus. Then this is acting as a acid. Okay. Over here, how the splitting will take place? It is this way: CH3, CH, CH3, O minus plus H plus. And here, how the splitting is going to take place? The bond which is going to break. It is this oxygen hydrogen bond which is going to break, right? So in this case, we have to look the one which is more stable. You're getting intermediate. This is what you are getting. So on which case the negative charge is more stable, right? So negative means what? If there is a negative charge, we have to know that this group, you should know this concept from the inductive effect. Okay, I have made a GOC video on this. You can also refer to that. Link is in the description where I have explained what is inductive effect. This is the group which is electron donating group. Electron donating group, right? All these methyls are electron donating. Means this shows a plus I effect. This group shows plus I effect. This group shows plus I, means electron donation. This all this group shows plus I. Means over here, what is the scenario? There is already negative. There is a negative charge, and this methyl group is making it more negative. Here there is already negative. There are two methyl group which is making it more negative. This is negative, and here there are three methyl group which is making it more negative. Means what we can understand from here is that already negative and making it more negative means it is something least stable. Here, the stability of this ion is least stable, least stable negative charge. Why least stable? Negative, already negative, and through inductive effect plus I effect, it is becoming more negative. Here also it is happening, but here there are just two groups, and here there are just one group. So which is more stable anion in this case? It is this, and least stable is this. So who will, in which case hydrogen will leave very easily, in which case the anion is more stable, in that case hydrogen will leave very easily. Okay, means when hydrogen leaves, I will write over here, when H plus leaves, the molecule leaves alcohol molecule, the anion form anion form should be stable. Right. So based on inductive effect, this is negative and it is making it more negative. But here, if you compare between the anion, this is the most unstable, already negative, and these are making it more and more negative. Yeah, here it is fine, just two, and here it is one. So most stable is this. So among this, who will give its hydrogen very easily? It is a primary alcohol, right? So if you compare among this, then the primary alcohol will donate primary alcohol will s- split very easily compared, when it is compared to what? Compared to secondary and tertiary alcohol. See, what I am doing over here is that I'm not comparing the acidity of the primary alcohol to that of the HCl or H2SO4. It is much less than that. But if I am comparing between a primary, secondary, and tertiary alcohol, the acidity of the primary is more than secondary and secondary is more than tertiary. This is what you have to remember. And that is how the whole concept is about the acidic nature of the alcohol. Next is a comparison between acidic strength of the alcohols. Okay, comparison between acidic strength of alcohols and phenols. Okay, let's take this. So R OH. This is alcohol. General way of writing a alcohol. And phenol is this. Phenol, I'll write it this way. This is phenol. So when alcohol, some processing is hampered over here. 1 minute. Yeah. When alcohol will dissociate, you will get this way. O minus plus H plus. And this is called as alkoxide ion. This is called as alkoxide ion. And what you will get over here, you are going to get uh, O minus and a H plus, right? What you get is a phenoxide ion. Phenoxide ion. Now, which negative charge is more stable? Which negative charge means alkoxide or phenoxide is more stable among this? Means this negative charge or this negative charge. If we see over here, this is the R group which shows the plus I effect, and this is the group like here there is a resonance, right? Here there is a withdrawal. Here the electron will be a resonating. This electron will be resonating. So something which is stabilized over here, intermediate is stabilized by resonance. Negative charge over here. In the case of phenoxide, I will write. In the case of understand that this is more stable. This phenoxide ion is more stable compared to this alkoxide. This is less stable, right? Reason what? Here negative charge, here negative charge, here negative charge on phenoxide ion is stabilized by resonance. So anything which is stabilized by resonance is always more stable. Remember this. It is stabilized by resonance. And whether it is a cation, the anion, if it is stabilized by resonance, then it is more stable. So this is stabilized by resonance. It shows a like plus M effect. It shows a plus M effect. Means to the benzene. Means electrons are donated to the conjugation. Means this negative charge is stable due to resonance. Right? So that's why what we can say is that phenol is more acidic than alcohol. Therefore, phenol is more acidic than alcohol.